In the year 2000, we produced enough food to feed 10 billion people. But we actually only fed less than 6 billion. And I'm going to tell you why. But before I do, I'm going to tell you a story about a man named Thomas Malthus. Thomas Malthus was born in England in the late 18th century during the Industrial Revolution. He was surrounded by people who thought that technological innovation could limitlessly increase human well-being, that technology will soon solve all of our problems and meet all of our wants and needs. But Malthus saw the world differently. He was one of 7 children, and he saw huge amounts of population growth in his time. So when Malthus looked at the world, he thought to himself, how are we going to feed everyone? So in 1798, Malthus published an essay on the principle of population. This essay made the observation that population growth in his time was exponential. And yet, crop production typically increases in a linear way. So eventually, we're going to reach a point in time in which population growth exceeds our capacity to produce food. And this will lead to a Malthusian catastrophe. There will be mass starvations at a global scale. And the future of our species will be severely limited by our ability to produce food. While it is true that about 1 billion people in the world are chronically malnourished today, the actual proportion of people who are malnourished has reduced in recent decades. Another thing that Malthus could not have foreseen is the slowing of population growth. So by 2050, we're expected to have about 9 billion people on planet Earth. But most demographers think that population is going to level off around 9 or 10 billion. Also, Malthus underestimated another critical thing, and that is the genius of University of Minnesota graduate students. But I'm not talking about myself. I'm talking about Norman Borlaug. He was a PhD, he got his PhD here at the University of Minnesota, and he developed a disease-resistant, high-yielding form of wheat. This development was able to increase wheat production in many countries. He first started out in Mexico and later brought his innovation to India and Pakistan. This innovation prevented what many thought was going to be a Malthusian catastrophe. So thanks to Norman Borlaug and others, we now produce enough food to feed everyone. So Malthus was wrong, right? Well, not necessarily, because we live in a changing world with growing demands for food. People are getting richer, and as they get richer, they demand more crop production. In fact, a professor here at the University of Minnesota found that by 2050, we're going to have to double crop production in order to meet increasing demands for crops. But let's investigate why that is for a second, because we're living in a world of about 7 billion people right now. We're adding about 2 billion by the year 2050. So that's about a 30% increase in population growth. So why is it then that we have to increase crop production by 100% by 2050? This is because of increasing demands for meat. There are 4 billion people in the world today who are increasing their meat consumption. They're entering the global middle class, which means they're getting wealthier. And as people get wealthier, they have a tendency to demand more meat. So in actual fact, per capita meat consumption is a higher driver of crop production demand than is population growth alone. And that's because meat production requires a lot of calories to produce. Beef production, for example, requires about 30 calories of crops to produce just 1 calorie of boneless beef. But beef is not the most efficient way of producing meat. So if we look at all different kinds of meat production, like chicken and pork, they can be more efficient. But on average, when we're feeding crops to animals, we only get about 10% of those calories back in a form that we can eat, in a form of meat and dairy. In other words, when we feed animals crops, we're losing 90% of the calories that we feed to them. This is a pretty big inefficiency in the system. So I wanted to figure out how meat consumption impacts global food supplies. To do this, I looked at crop production in the year 2000. This map shows places in the world where we produce a lot of calories in the red. And these crop data for the year 2000, which is the most current data that we have. So if we look at global calorie production, and we figure out how we're using these calories that we produce, because we direct a significant proportion of our crops to animals for feed, and also increasingly we're using human edible crops for biofuels. So on a global scale, if we can figure out how we're using these crops, either in terms of food that we directly consume or feed that we consume indirectly after they're converted to meat and dairy, we can figure out what proportion of all of the calories that we grow actually end up delivered to people in the form of food. So looking at a global scale, we can look at how we're using our crops. This map shows the fraction of crop production that is used for food in the red, and the fraction of crop production that is used for feed and biofuels in the blue. So you'll notice places like India have lots of food production, whereas the Midwest in the United States directs a higher proportion of their crop production to feed. And on a global basis, about 36% of the calories that we produce globally go to animals for feed. So we can translate these data into what proportion of all of the calories that we grow actually become available as food that you and I can eat. So the green areas in this map show where high proportions of the calories that we produce are delivered to people. And the red areas in this map show where we're directing a lot of our crop production to animals and biofuels, and therefore a very small proportion of those calories get delivered to us as food. On a global basis, only about 59% of the calories that we grow on global croplands actually become food. And you might be sitting there thinking, well, hold on a second, I know that we're losing calories to this conversion process, but we need meat because we need protein in our diets. And while that is true that we do need protein in our diets, we're actually losing protein in this conversion process too. So out of all of the protein that we grow on croplands, only about 50% of that protein becomes food. But this delivery fraction differs by the country that you're in and how you're using your crops. So in China, for example, they use about 1/3 of their crop production for animal feed, which means most of the calories that they produce actually end up in the food system, about 62%. In the United States, we see almost the opposite happening. Over 2/3 of the calories that we grow here in the US are used for animal feed, which means that out of all of the calories that we produce here in the US, only 34% of those calories become food. This is a pretty big inefficiency in the system, especially when you consider how many people we can actually feed. The US is one of the most productive agricultural systems. We could feed 16 people per hectare if we ate everything that we grew. Whereas if you look at a country like India, they produce less than half of the calories that we produce. Yet because most of their crop production is used for food, they're actually able to feed more people per hectare than we are here in the US. But this is not so surprising when you consider that per capita meat consumption in the US is pretty big. We have one of the highest per capita meat consumptions out of any place in the world. Our meat consumption is far beyond nutritional recommendations, and many recent studies have found that high proportions of meat production or consumption are actually bad for our health too. They can cause certain kinds of cancers as well as heart disease. So if we're looking at the global food system in the year 2000, we can figure out how many people we could feed if we ate everything that we grew and we stopped producing biofuels from crops. We could feed 10 people per hectare. And it turns out there are about 1 billion hectares under cultivation for these crops. So that's about 10 billion people. But when you look at the calories that actually become available in the food system, on the actual food supply in the year 2000, it's only about 6 people per hectare, which is about 6 billion people. And it's important to note that we're not including other forms of waste in this, which can take an additional third of those calories out of the system from transportation and storage losses, as well as post-retail losses. So where do we go from here? How does what I just said impact global food security and the future of food? Well, we need to think about the way that we're currently using our croplands, because putting more land into cultivation in recent years has meant cutting down the rainforests in the tropics. This is deforestation that happened in between 1992 and 2008 in the Brazilian Amazon. It's important to note that most of this deforestation happened for agricultural purposes. Most of it is for either beef cattle production or soybean feed that is later exported. So you might be sitting there thinking, well, we can just innovate our way out of this problem. We can increase crop yields in the land that we currently have, and we can solve it. And while it is true that in some places in the world we are seeing increasing yields, like this is a study done by a colleague in my lab, which shows places in the world where we have increasing maize or corn yields. So you'll see places in the Midwest of the United States and Eastern Europe and some places in Argentina, we're still seeing increases in corn yields. But if you look at another crop, rice for instance, you'll see that while there are some yield improvements in some places, there are also lots of areas with yield stagnation. The same goes for wheat. If you look at wheat, about 35% of the land under cultivation for wheat, their yields are stagnating. This is important and very scary when you consider the fact that although lots of places in the world have increasing corn yields, that doesn't translate to very many people fed. Whereas when we look at wheat and rice, we depend much more on those crops for our food supply. So if we're thinking about the future of food, we need to think about how we're investing in which crops and if they're actually feeding people. So back to Thomas Malthus. Although Malthus might have been wrong that population was the driver of increasing crop demand, he might not have been wrong about the idea that we might not be able to meet future food demands. But the good news is that diet preferences are a lot easier to change than population growth. So what can you do about this? Well, let's just say hypothetically, everyone became vegan and we didn't produce any biofuels from crops. We could increase calorie availability by 70%. That's enough calories to feed an additional 4 billion people. And you might be sitting there this whole time thinking that that's what I'm advocating, that I'm saying, stop eating meat, everyone. But I'm not, because I love cheese and bacon. And I'm sure you do too. So what am I asking you to do? Well, reducing meat consumption is not only good for the environment, it's good for your body too. Also, just switching the kinds of meat that we eat can have big efficiency improvements. So as I mentioned before, beef is not the most efficient converter of crops to meat. So if we just switched from beef to chicken and pork, we might see some efficiency improvements. And I actually did this calculation. I wondered, if everyone who ate beef just ate chicken and pork instead, how many additional calories can we get from that efficiency improvement? And what I found is the additional calories that we could get just from switching from beef to pork and chicken could feed an additional 300 million people. That's about the population of the United States. So the take-home message is that diet matters. If we want to think about sustainably feeding a future population with increasing demands for food and for meat, we need to think about using the land that we currently have. And then as it turns out, the decisions that you make every day about what to eat have huge implications for our ability to meet future food demands. Thank you.